It's Friday. I know that y'all are excited and ready for this Friday. I hope that you guys have a good day and that you have a great weekend. I'm going to jump into the homework from last night. I'm just going to go through them all real quickly. And then, like I promised you yesterday, today you're going to get a review tomorrow, or sorry, Monday when I get back. We'll go through that review for a little quiz. So you'll have a quiz in here on Tuesday of next week. It'll be the first quiz um, for this 9 weeks. Okay? So here we go. We're going to go through this, try to make this as easy as possible. This was the homework from Wednesday night, and you were supposed to do the last four for homework last night. Then we're going to jump into the other one. Then I'm going to show you just one thing real quickly on the review, and then you have the rest of class time to do it, okay? So here we go. I'm going to go ahead, like we said yesterday, and I'm going to go ahead and draw my right triangle. And I'm going to put theta right here, okay? What did they give me this time? They gave me tangent. So first of all, I know if tangent is 4 over 3, then my cotangent is going to be 3 over 4. Okay, I got that knocked out of the way. Don't have to think about that anymore. But let's think about tangent. Remember, tangent is TOA. That's opposite over adjacent. So remember, I decided where my theta was going to be. I decided it. So from that theta, the opposite leg, as we can see, is 4. So the opposite leg is 4. And the adjacent leg is 3, TOA, right? So now all we got to do is find what in this part, in this problem? We got to find the hypotenuse. So I'm going to do 3 squared plus 4 squared equals the hypotenuse squared. Okay? So you can type in your calculator 3 squared plus 4 squared. That's 9 plus 16. And you're going to get 25. 25. And that equals x squared. So the last thing I'm going to do is take the square root of both sides, and the square root of 25 is 5. So my hypotenuse here is 5. So now I can easily write all of these trig functions. So let's start with sine. Remember, sine from theta is opposite leg 4 over the hypotenuse 5. So let's flip it for this one. Okay, cosine. It's adjacent leg 3 over the hypotenuse 5. And then for secant, we will flip it. Done. Easy peasy. I hope that you guys are understanding this. I think as you go, it gets easier and easier because you just see the consistency of it. So let's look at this problem. I'm going to go ahead and draw my right triangle. I'm going to go ahead and take the cosecant, which is square root of 13 over 2, and I'm going to find the sine then as 2 over the square root of 13. Now, you can rationalize that denominator here in just a second, but I want us to think about it from theta. What do we have here? Sine, right? Sine is so. That's opposite over hypotenuse. So I'm going to go up here to my graph, and across from the theta, that's my opposite leg, I'm going to put my 2 over my hypotenuse, which is across from my 90 degree angle, that's square root of 13. So this time we have the hypotenuse. We're trying to find our other leg. So I'm going to go x squared plus 2 squared equals the square root of 13 squared. Now let's type that into our calculator. That's 13, the square root of 13 squared, the square root and the square cancel. That's 13 minus 4, 2 squared. 13 minus 4 is 9. So we're going to take the square root of that, and the square root of 9 is 3. So this other leg here is 3. So now we can answer all of our questions quite easily. Okay, cosine. Adjacent over hypotenuse. That's 3 over the square root of 13. Now, real quickly, while we're on those two problems, again, I'm 100% fine with you leaving them like that, but I just want to remind you, in case you rationalize the denominator, you multiply both of those by the square root of 13 over square root of 13, and that will cause the numerator to have it with it and the denominator to cancel. So there is what you would have if you rationalize the denominator. Now, if the cosine, and let's go back to the original, was 3 over square root of 13, secant is the square root of 13 over 3. And then finally, tangent is opposite leg 2 over adjacent leg 3. And then let's flip it. All right? Easy. Let's keep on moving. This time they gave me sine. Let's go ahead and draw our graph. We kind of already did one with sine right there, didn't we? So I'm not going to spend too much time on it. This we flip, of course. For sine, we have opposite over hypotenuse, just like the last problem. Because we didn't really do cosecant. We prefer changing it and working with sine, since that's one of the majors. So opposite from the theta is 5, and hypotenuse from the theta is 6. So once again, we're looking for a leg. So x squared plus 5 squared equals 6 squared. So we're going to subtract 6 squared minus 5 squared. And if you do that, 6 squared minus 5 squared is 11. So x squared equals 11. We're going to take the square root of it. So x will equal the square root of 11. Think about it. I can't simplify that. So if I can't simplify it, I'm just going to leave it be. So my adjacent leg is the square root of 11. All right, so here we go. I didn't have to erase that, I guess. Cosine. The adjacent leg, square root of 11, over the hypotenuse, 6. For secant, we flip it, 6 over the square root of 11. And if you were to rationalize that, you would multiply by the square root of 11 over square root of 11. So it would be 6 square root of 11 over 11. Last one, tangent, is opposite leg over adjacent leg, TOA. So that's 5 over the square root of 11. And if you rationalize that, that would be 5 square root of 11 over 11. And of course, for cotangent, I simply flip that original one, square root of 11 over 5. All right, one last one, number 10. And this one did secant. So if secant is 13 over 5, I know that cosine is 5 over 13. So when I go draw this thing, put my 90-degree angle, same place, put my theta in the same place. Here we're doing adjacent leg over hypotenuse. So the adjacent leg is 5, and the hypotenuse is 13. So once again, we're trying to find a leg. So here we go. A squared plus b squared equals c squared. So we're going to subtract 13 squared minus 5 squared is 144. So x squared equals 144. If you take the square root of 144, it's a perfect square. X equals 12. Boom. So here we go. Sine is opposite leg, 12, over hypotenuse, 13. Flip it for cosecant. Tangent is opposite, 12, over adjacent, 5. And then flip it for cotangent. And that is how you do it, okay? Very simple problems. You're actually not going to have any of those in the review. We're going to focus more on the other ones. Let's go check those out now. So let's open up the angle, or open up. I'm opening up. You grab the other homework page that you got, and I want you to picture these once again. Same concept, okay? All of this is the same concept, except the direction of your x and y will change, of course, what your sine, cosine, tangent is going to be, because you might have one that's negative. In fact, let me just tell you this, because we're going to get back to it soon. There's this little saying, it's called all students take calculus. All students take calculus. And what that tells me is this, and listen to this real quick. I didn't go over this yesterday, and it doesn't really matter. So, because of the direction of this x and y value, sometimes x and y will point will point the triangle over here. Well, in quadrant 1, all of my, trying to write and it's not keeping up with me, all of my trig functions will be positive. All of them. Sine, cosine, and tangent. Now, obviously, if sine is negative, cosecant is negative. If sine is positive, cosecant is negative. So we're just talking about our majors. Okay, so in quadrant 1, they're all going to be positive. In quadrant 2, only sine will be positive. The rest of them will be negative. Okay? I'll show you that in just a second. So in quadrant 3, what does that mean? Well, only tangent is positive in quadrant 3. And then in quadrant 4, only cosine is positive. And you're going to see that. And this is something we'll talk about again later. I don't know why I erased it. But watch this. This one clearly created the angle in quadrant 2. So with that being the case, what should be positive? My sine. And watch this. If my adjacent leg is negative 5, that's my x. And if my y value, right, if my y value is 12, let's find real quickly the hypotenuse. So we go negative 5 squared plus 12 squared equals the hypotenuse, or r squared. So negative 5 squared, and remember, please put that in parentheses before you square it, plus 12 squared is going to give me 169. So 169 equals x squared. We take the square root of that, and we get 13. So my hypotenuse here is 13. So watch this. If I'm coming from this angle right here, like we did yesterday in the homework, if I'm coming from this angle right here, what's the opposite leg for sine? The opposite leg is 12. What's the hypotenuse? 13. See? 12 over 13 is positive. But then look at cosine. Cosine is adjacent leg. That's negative 5. Over the hypotenuse, that's positive 13. Look, cosine's negative. See, in quadrant 2, only sine is positive. In fact, one more proof. Look at tangent. Opposite leg, 12, TOA, right? 12 over the adjacent leg, negative 5. So sure enough, it's negative as well. So in the second quadrant, only sine will be positive. Now, your minor one, of course, cosecant will be positive as well. Okay? It goes with whatever sine is, it is. For secant, I switch those, flip them over, negative 13 over 5. For tangent, I flip those over, negative 5 over 12. Done. Okay? All right, number 20. Number 20 is 2, 8. So look, I'm going right 2, that's x, right 2, and I'm going up 8. So positive 2, positive 8. And then, of course, here's where that angle is being created, right here. All right, that's theta. So we're coming from that angle. And I probably could draw that a little bigger. I'll just kind of zoom in on it. But notice what quadrant it's in. It's in quadrant 1. All of my trig functions should be positive. Now let's find our hypotenuse. So we're going to do 2 squared plus 8 squared equals my hypotenuse, x, r, whatever you want to call it, c squared. So 2 squared plus 8 squared equals 68. 68. Now I'm going to take the square root of both sides. And yeah, 68 is not a perfect square. But let's see if there's a perfect square that goes into it. If I divide that by 2, it's 34. I'm not going to try a perfect square above 34. So 68 divided by 25 I know doesn't work. 68 divided by 16 doesn't work. 68 divided by 9 doesn't work. 68 divided by 4 does work. 17 times. So 4 goes into that 17 times. So 4 gets to break out as a 2, and then square root of 17 stays inside. So my hypotenuse here is 2 square root of 17. So let's write our sine, cosine, and tangent. Sine, that's opposite leg, 8, over the hypotenuse, 2 square root of 17. Now, this is a little different than any of the problems we've had up to this point, because if you notice, won't 8 over 2 reduce? 2 goes into both of those. 2 goes into 8 4 times, and it goes into 2 once, so it kind of cancels. So sine, simplified, is 4 over the square root of 17. Now for cosecant, I'm going to do square root of 17 over 4. But also, if I chose to rationalize the denominator, that answer would be 4 square root of 17 over 17. So remember, I'll take either of those. I'm 100% fine with that. Now let's look at the next one, cosine. Cosine is adjacent leg, as you can see there. From my theta, here's my adjacent leg. I colored it in a little darker. It's 2 over the hypotenuse, which is 2 square root of 17. Well, once again, 2 over 2 reduces. That's 1 over the square root of 17. Okay, so the secant is just going to be the square root of 17 over 1. So square root of 17. So the other thing I could have done is I could have rationalized the denominator, and I've gotten 1 times square root of 17, which is square root of 17, over 17. All right, and then lastly, tangent. Tangent is opposite leg. Opposite leg, of course, is 8. We talked about that earlier. Divided by adjacent leg, which is 2. Well, that is 4, because 8 divided by 2 is 4. So my tangent is 4. Now remember, it's technically 4 over 1, so cotangent is 1 over 4. So that kind of had a little trick to it. Maybe some of y'all got a little stumped or puzzled on that one. Well, there it is. There's how you do it. Not overly difficult, but it was the first one that you saw that kind of had those tricks. Okay, last one, 21. Without looking, well, actually, you can look. If I went 3 right and I went down 6, what quadrant am I in? Well, it's definitely in quadrant 4. So in quadrant 4, what's the rule? Remember, all students take calculus. Only cosine should end up being positive. Now, of course, since that one was positive, secant's positive. Let's see if that's true. Here we go. Let's find our hypotenuse. So 3 squared plus, in parentheses, negative 6 squared equals my hypotenuse squared. And I called it C this time. I called it X earlier. I could have called it R. It doesn't matter. So I'm going to do 3 squared plus negative 6 squared, and I'm going to get 45. 45 is C squared. I'm going to take the square root, and 45. I know it's not a perfect square, so let's think about it. 45 divided by 2 is 22.5. 16 won't go into it. 9 will. 9 goes in there 5 times. So C, this breaks out as a 3. C is 3 square root of 5. So similar to the last problem we're going to see. Watch. Sine. Opposite leg, that's negative 6. Over hypotenuse, that's 3 square root of 5. Now, again, kind of like that last one, look at this. Negative 6 divided by 3 is negative 2 over 1. So for cosecant, I'm going to flip that. That's going to be square root of 5 over negative 2. And I just put it out front because that's fine. Now, the only other thing I could have done is on sine, I could have rationalized the denominator, and it would have been negative 2 square root of 5 over 5. Words are hard today for me. Struggling a little bit. So there's your sine and cosecant. Notice they're both negative. I already told you that. Only one that's going to be positive is cosine and secant. So let's prove it. Cosine. Cosine is adjacent leg, 3, over hypotenuse, 3 square root of 5. And sure enough, the 3 over 3 will be 1 over the square root of 5, and boom, positive. Flip it, that's square root of 5 over 1, and then the only other thing I could have done here is I could have rationalized this denominator. It'd been 1 times the square root of 5 over 5. Again, I'm not going to lose sleep over those if you don't do that, but that would be the answer in an acceptable form as far as in a multiple choice. But notice how cosine and secant are both positive. And then the last one, opposite leg, which is negative 6, over the tangent, or I'm sorry, the adjacent leg, which is 3. Negative 6 divided by 3 is negative 2. And then, of course, if I flip it, that's technically negative 2 over 1, so it's negative 1 over 2. Okay, look, once again, tangent and cotangent are negative. The only one that ended up being positive is cosine. Why? Because that's just the way it works when it moves in those directions. All students take calculus. So quadrant 1, all of them are positive. Quadrant 2, sine is positive. Quadrant 3, tangent is positive. And like we just saw in quadrant 4, cosine is positive. So there you have it. That was your homework from last night. We went through every problem. So that should get you started on your homework or your classwork that you currently have. Well, I want that open. There you go. So here is your review. It's coming, or you already have it. Depends on whether or not your substitute wanted to go ahead and give it to you. Here it is. All of this is really simple, 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 simple. This is what it's talking about. It's what we just did. Remember, let theta be in standard form and xy be on a point of a terminal side. That's what we just did. So that's what you're going to apply on the back. And it's really 2 pages, mainly to get your extra practice in case you needed it. So no excuses for y'all not to work on this. No excuses not to get this done. Okay, it's pretty straightforward, pretty simple. The sketches are pretty easy. Converting, remember, multiply by pi over 180. To do number 4 through 6, multiply by 180 over pi to do 7 through 9. Number 10, 11, and 12, you're going to name 2 coterminal angles, positive and negative. And then, of course, you're going to do those problems. You're going to run them back just like we have, okay? Just like we just did. All right, hey, you have the rest of class time to work on this. I'm looking at the video's length right now. We're at 21 minutes, so you have about 25 more minutes left, maybe 24. Bless me. Again. All right, well, hey, have a great weekend. Monday we'll go over this. If you have any questions over any of the stuff that I've done the last 2 days, it's on here. And, of course, you can mark it and ask me tomorrow on Monday. All right, have a great weekend.